Hello and welcome to m200 Online Statistics at Cañada College. My name is Lapuz. In this video we will do a homework problem from section 7.4. It says that the body mass index or BMI for a sample of men and a sample of women are given below. Assume the samples are simple and random and they're obtained from a population with normal distributions. Part A wants us to find a confidence interval, 99% confidence interval for men for the standard deviation, and I'm assuming that the next one is going to be to find the confidence interval estimate for the standard deviation for women. Let's copy this into our clipboard and paste it into our Google Sheets. Now we're going to have to do this one by one, and let's temporarily paste the data for the men and women somewhere else, and then I'm just going to grab the data for the men and I'll paste that in my first column here. Now for this we want to find the following. We want to find the standard deviation, S. We want to find the N, the sample size. We want this at the 99% confidence. Got too many percent signs. And then we want to find the chi-squared left and chi-squared right critical values. And then we're going to use this formula to find the upper and lower bounds. Alright. Let's start with the standard deviation. That's pretty simple, STDEV, and we'll click and drag the data, and then the sample size is just going to be the number of numbers here, which is going to be 10. Now we want to find our confidence interval or critical value first. In order to find a critical value, what we need to do is we need to find the area to the left of the critical value. So if the middle of the data set is 99%, then you have 1% combined on both sides, but you only want, on the left side, you want half of that. So this is going to be, let's put a parentheses around, it's going to be 1 minus the confidence level and divide that by 2. So 1 minus confidence level is 1%, 0.01, and then we're going to divide this by 2 and you get 0.005. Now the tail on the right side is also going to be 0.005, but when we want to find that right critical value, we need to find the area to the left of that. Well, the area to the left of that is really just a complement of this tail, which is going to be 1 minus that number. And the area to the left of the right critical value is going to be 0.995. Okay, these two numbers will help us find our chi-square inverse, our critical chi-square values. So let's take the left side first, where the area to the left is 0.05. That's pretty straightforward. So the command or the formula is CHISQ dot INV. And if you take a look at that, it says calculates the inverse of the left tail chi-square value. So the probability was the area on the left side of the left tail, 0.05. comma, and then they want us to find the degrees of freedom, which is going to be n minus 1. So it looks like our right tail critical value is 1.7349. Now to get our next one, we got the same chi-SQ dot INV. And this time the area to the left of the right critical value is a bigger number, 0.995. So I'll click on that, and then we have n minus 1. So that's 9. If you noticed, you can also do, this might be easier, but this command doesn't always exist in some of the spreadsheets. But let's just say if you have that particular command, you can type the CHISQ.INV.RT to say it's the right. And then if we put this value 0.005, and then our n minus 1 was 9, we're going to get the same result as what we got. Okay, so however way you want to do it with our current Google Sheets version, then that'll work. Alright, we have chi-square left and chi-square right, and so now let's find the lower bound. Notice that the lower bound uses the chi-square right value. Okay, so this is going to be the square root of n minus 1. You can just put 9, or if you want to use a formula, we can do the parentheses and then n and then subtract 1 times the standard deviation squared, and then we'll divide by chi-square right, and we'll close the parentheses for the square root and press enter, and so now we have the lower bound. The upper bound is similar. We'll say equals the square root, an extra parentheses, and then n minus 1. So the n was equal to 10, subtract 1, close parentheses, times the standard deviation squared, divided by chi-square left this time, and close the parentheses. Okay. Alright, so it looks like we got 2.099, 7.7427. Our data set was originally rounded off to 1 decimal point, so I think we're going to want to round off to 2 decimal places here. So let's highlight this and round off to just 2 decimal places, and that'll be 2.10 and 7.74. Let's try that. 2.1 and 7.74. Okay. Now they want us to do the same thing for women. The neat thing about this particular problem is that we had already set the formulas here for the standard deviation. We know that n is equal to 10, this is 99, and then all these other numbers go as follows. So if we take our data set for the women, let me copy this and paste it over here where the men were, the numbers will change. And so we will have a different S, but our n will be the same, and now all these numbers will change accordingly. Notice I did not have to do any work at all aside from copy and paste. And our results here are 3.93 and 14.49. 3.93, 14.49. 3.93, 14.49. Okay. We have one more follow-up question. Compare and interpret the results. Let's take a look at these results, and we see that 2.1 and 7.79 body mass index for men, and for women it starts off higher and it goes all the way up to 14. So it looks like they overlap. They overlap a little bit. Men tend to have lower body mass index, So if you take a look at the lower bounds for them, they're both lower, and the upper bounds are also lower. And let's see what they have to say. Since intervals overlap, the population appear to have different amounts of variation. Well, if they overlap, I think they're close to the same. Since the intervals overlap, the population seem to have amounts of variation that are not substantially different. So I think it's this one. The other two say that they do not overlap, but it looks like they do overlap by looking at these numbers. So we'll say B, that they overlap and they are not significantly different. Alright, I hope that helps.